Are we the last technologically advanced civilization ever on Earth? It's possible. Humanity has risen to the position of the dominant species on the planet, 8 billion strong. We have planes, cars, robotics, advanced computers, and the capacity to send our spacecraft to distant celestial objects, and soon maybe we will even travel there ourselves. And yet, Rome wasn't built in a day, nor without cost. It has taken billions of tons of coal, oil, and natural gas to fuel the industrial revolutions that have made society into what it is today. Those resources are not infinite, and they will take millions of years to replenish themselves. Which begs an interesting question. Was this a one-time deal? If something were to happen to civilization, if some cataclysm or nuclear holocaust were to send us all technologically back to the Stone Age, or even wipe us out completely, are there enough resources left that some future civilization could rebuild? Or are we now the first and last civilization birthed by our Earth that will ever reach for the stars? And if so, why? I'm Alex McColgan and you're listening to the Astrum podcast. And today we will explore the rise of our technologically advanced society and learn what materials you need to build what we now have. And then we will discover how much of those vital ingredients are left. But for the sake of this thought experiment, let's start by activating Doomsday right now. Boom! In one fell swoop, humanity has been sent back to the Stone Age. All technology has been annihilated, perhaps in a horrific nuclear exchange. Human society has collapsed. Whoever survived is now tasked with rebuilding civilization in a world with no buildings, no machines, no books, and perhaps worst of all, no internet. Let's say for the sake of this thought experiment that natural resources are unharmed, but nothing can be salvaged from the civilization before. Like the ultimate survival game, everything must be built from scratch. Once our survivors have gotten over the shock of this horrifying turn of events, they will quickly realize that they need at least 3 vital things if they want to live: food, clothing, and shelter. And fortunately, these are all accessible through various renewable sources. These will not be the limiting factors when it comes to restarting civilization. With wood, you have building materials. Wool or cotton can be woven into clothing. Animals, vegetables, and fruit can be hunted and gathered for sustenance. Conveniently, these natural resources can be accessed with some very simple tools. Some sharp sticks for hunting and fishing, and some simple axes and knives for chopping and fashioning wood, made out of nothing more than sharp stones tied to sticks with hempen rope. With this at its base, a civilization that develops after us could absolutely and easily reach a thriving hunter-gatherer society. We should even be able to get further than that, although if our civilization is ever going to get to the stars again, they will need to start by stepping up from stone tools to bronze and iron. For bronze, an alloy made from mixing tin and copper, wood-burning fires will be enough to get by. Metal ores extracted from the ground need to be melted to separate the rock and impurities. Smelting tin requires temperatures of 230 degrees Celsius, and smelting copper needs a little under 1100 degrees Celsius. Fortunately, a large wood-based bonfire can reach temperatures of 1100 degrees Celsius, making bronze just about accessible to our new civilization. But it is with iron that the problem comes into a focus. Iron is tricky. While this metal is extremely plentiful in the Earth's crust, its melting point of 1583 degrees Celsius means our fledgling civilization would need to do more than just place it on a wood-based bonfire to be able to smelt it. Fortunately, there are workarounds to this problem. By partially burning wood in low oxygen conditions, you can make charcoal, which burns at a higher temperature than the wood it's formed from due to the fact that the initial combustion cost of getting rid of all that water and sap has already been paid. This can be further enhanced by placing your fire in a kiln and controlling airflows. With the right flow, even a wood-burning fire can reach temperatures of 1,500 degrees Celsius, such as with the record-breaking Sunan snake kiln in Taiwan. But using charcoal comes at a cost. You need a lot of forestry if you're going to get enough wood to support a metal-hungry civilization. It will need to be replanted regularly, but more crucially, you won't be able to turn that land into farmland, something your civilization will also need if it wants to grow and develop. This is why most nations use fossil fuels to produce their steel. Coal or methane gas can be used to create incredibly hot fires, without requiring you to give up your farmland. You might be wondering if our new civilization could do without these fossil fuels. If we just grew a little more slowly, with a smaller population, couldn't we make charcoal work? Charcoal is carbon neutral, as the trees that create it grow it by removing carbon from the atmosphere. Couldn't a new civilization reach our level and get to space again without using fossil fuels in their production? The answer is no. The absence of fossil fuels would be devastating to a civilization trying to reach for the stars. This may be an uncomfortable thought, but just consider for a moment the degree to which our own civilization uses coal, oil, and gas. Now, I'm not advocating that we don't need to do better. Just because we currently use a lot of fossil fuels as a species doesn't mean we shouldn't try and reduce and care better for the planet. When we talk about using fossil fuels, it's easy to think about them only in terms of electricity production, which our new civilization would need to get to if it wanted to get back to space travel. In fairness, fossil fuels remain the world's primary energy source. In 2022, 83% of the world's energy came from these sources. But fossil fuels are also incredibly important in the production of 4 other vital ingredients for our civilization. I've already mentioned steel, for which our current global demand sits at 1.8 billion tons a year due to its strength and durability as a building material, but there is also concrete, plastic, ammonia, and silicon. Can you imagine a world without concrete? Without fossil fuels? You would probably have to. The sand and gravel that makes concrete up are easy enough to acquire, but the cement that binds it all together, made from a mixture of limestone and clay, requires temperatures of 1,400 degrees Celsius to melt them together properly. If our new civilization wanted to make concrete, which would be useful as it's an extremely malleable, durable building material, useful for building a spaceport for launches and many other buildings and platforms, they would need to find a fuel that could burn at that temperature. The civilization that comes after us would need a lot of charcoal to fill the gap if fossil fuels were no longer on the table. But that's not even an option for silicon. Silicon has widespread use in our society, from ceramics to brickwork, but by far its most influential trait is that, once refined and purified, it's the element used to make computer chips, thanks to its abundance and its properties as a semiconductor. It's extremely easy to find in its raw form, but refining it is a complex process that requires temperatures of 2,350 degrees Celsius. Charcoal does not burn that hot. Not for nothing have the last 100 years been referred to by some as the Silicon Age. Can you imagine our world without computer chips? In terms of getting to space, the computers that guide and control the launch of a rocket would certainly struggle without computer chips. There's more. Ignoring materials that simply need high heat to smelt or refine, fossil fuels are literally a building material we use to make our products and feed our population. While we sometimes express concern about the amount of plastic being used in the world, there's no denying its importance to modern civilization. It makes keyboards, boxes, sterile tubes, and syringes for medical applications, polyester clothing, car bumpers, wind turbines. Yes, even green energy sources like wind turbines are made out of materials that require fossil fuels. A wind turbine is around 70% steel and 10% plastic. Both are fossil fuel reliant. Plastics are also used in rocketry. Having a lightweight material that's easy to mold, fairly rigid, and above all, light, is extremely useful for rockets that are trying to shave every gram of weight off. Launching without plastics makes rockets much heavier, requiring more fuel or smaller payloads. Finally, let's consider ammonia. While you might think we could do without plastic in our lives, without ammonia, it is likely that about half of the Earth's present population would starve to death, which, while not directly related to getting to space, is a bit of a problem on its own. Ammonia is used in fertilizer. Although other natural fertilizers exist, they lack the potency provided by ammonia. Without ammonia, we simply would not be able to sustain the amount of food production that we need to support the global population, not by half. And ammonia is made from methane, which is mainly sourced from natural gases. When viewed through this lens, it's easy to see the scale of the challenge that would be faced by a civilization trying to reach a technological level where they could explore space if they didn't want to or didn't have access to fossil fuels. And let's be honest, the easiest to get to fossil fuels on Earth are now mostly gone. You need serious equipment to get to the fossil fuels we are now extracting, which required fossil fuels in the first place to build. Our civilization has been built on the back of fossil fuels. They provide our plastic, our steel, our concrete for our buildings, and our energy. Without them, we would struggle to produce the metal for a rocket or the fuel that powers it with the computers that guide it. And so, for the sake of our thought experiment, how much fossil fuels have we used? And is there enough left so that the civilization that came after us could do it all again if they really had to? It's difficult to find estimates that accurately lay out how much fossil fuels have been used up by this point. Our current usage is at around 15 billion metric tons per year, although this figure has been climbing for some time, so will likely continue to increase as our population does. However, by projecting our current usage back across the past, and by factoring in the increase in demand over time since 1800s, when the Industrial Revolution roughly began, it's possible to arrive at a ballpark estimate of 750 billion metric tons of fossil fuels consumed by the human race to get to where we are now, by multiplying our current yearly usage by the number of years between 1800 and now, and then approximately quartering the result, to reflect the fact that demand was considerably lower most of that time. Now, we do not know how much fossil fuels we have left. Current estimates based on proven reserves suggest that we will start running out of fossil fuels in just 50 years' time. Coal will last longer. Coal reserves should keep the lights on for up to 130 years, but oil and natural gas could potentially all be used up in the lifetime of people around today. Calculating based on our current usage, this works out to at least another 750 billion tons of fossil fuels remaining, the same amount that got us to this point, only we're currently burning through it much faster. Of course, this number could be much higher. This estimate is based only on proven reserves. If more oil fields are found, or technology is developed that can allow us to access fossil fuels better, the amount of fossil fuels available in the planet could be a lot higher than current estimates. Still, this is enough information to provide us with our answer. A civilization that rises after us would indeed have enough resources to get to the same technological level that we are currently at. But they would likely find it much harder, as much of those untapped fossil fuel reserves are buried at much deeper depths than the ones our own civilization found. We have burned the supplies that were easy to get to. In 1950, the average depth you needed to drill to access oil was 1.1 kilometers. This now stands at 1.8 kilometers, but some oil and gas fields are as deep as 9.1 kilometers. It wouldn't be easy, but the resources are currently there, for now. If we ask this question again in 50 years' time, we might arrive at a different answer. It might be necessary for future civilizations to get used to the idea of a more comfortable, arable existence. Still, if there is a ray of hope to shine on this, it is that necessity is the master of innovation. The materials we use are the most effective at what they do, but that's not to say that with sufficient will, a new civilization that comes after us couldn't get to the stars again even without fossil fuels. They might need to go slower, their population might never reach our levels, and many would have to make do with rougher tools or suboptimal materials. But where there is a will, there is a way. Perhaps the future civilization will one day harvest methane from bio-waste. Methane can be used as rocket fuel. Without fossil fuels, the civilizations that came after us would look very different from our own. They would have different priorities and would perhaps use their land with a different focus in mind. But perhaps they could get to the stars in their own way. Thanks for listening. If you've enjoyed what you've heard, please feel free to follow us for more podcasts on other fascinating space topics. But for now, I'm Alex McColgan, and this has been Astrum. All the best, and see you next time.